Hello everyone, thanks for joining and thanks for the introduction, Ellen. As you can see from the title of this presentation, I'll be showing you some functionality from the UKFE package. But there was a bit of a hurdle. I thought just showing you functions and typing away at a command line and pressing enter all the time might get incredibly boring. And a wise man once said to me that the best presentations are ones where there's a personality, a personal story. So I'm going to provide my personal story and my progress, which led to the development of UKFE. I'll then provide probably the shortest introduction to the Flood Estimation Handbook you've ever heard, and a similar one for the R and R packages before I start showing the functionality. And then hopefully you can answer that question yourself once you've seen the functionality. Can it be of use to you? So after doing a BSc in physical geography, I joined the Environment Agency at the Thames Barrier in about 2005 December, and in doing so I was doing lots of GIS work, answering customer inquiries, mostly making nice maps and things, and gaining lots of interesting facts about the Thames Barrier, the Thames Estuary 2100 project, etc. And maybe the most interesting thing, at least for outsiders, I did was do some modelling with Flood Modeler Pro, which was for the which was called ISIS back then, of course, for the Queen's, I think it was Diamond Jubilee, the river pageant. So in that case, we closed the barrier in a different way. Rather than keeping the tide out, we were keeping the tide in, sorry, for a sort of test. And this was so that we could have enough water for the boats. But we didn't want too much water, so that the Queen got her hat knocked off when she was going under a bridge. So I did some modelling with Flood Modeler Pro to make sure we closed at the right time. That's the idea. Anyway, after about 5 years of this, the Environment Agency had a restructuring, and although I was still physically based at the barrier, I was moved to a team, the Thames, I think it was called the Thames Modelling Team, Inland Modelling Team or something. But all the focus was mostly inland flooding, and the FEH Flood Estimation Handbook became quite important. And I didn't really live up to my title at the time, which was technical specialist, because I knew nothing about the Flood Estimation Handbook and rainfall runoff modelling and all this sort of stuff. And at about this time, I was still wondering what I was going to do with my career. So even after 5 or 6 years doing this, I was thinking, what could I be? Could I be, you know, an astronaut or an Olympic athlete, or maybe even a tugboat captain or something like that? I was still a bit confused. Then it dawned on me that maybe, just maybe, I already am something. Maybe I'm a flood hydrologist, and this is my career. So I decided then, right, if this is my career, I'm going to buckle down and get good at it and get stuck in. So in doing so, I thought the best place to start was get into the fundamental knowledge of what a return period was and how to calculate one. So I opened up the Flood Estimation Handbook and started reading, and I saw pages like this where I thought, what the devil's all that? I had no idea what any of it meant, and I realized I was a complete nincompoop, but I could barely remember the difference between a mean, mode, and a median. So I had to go back to basics and read some books such as Statistics Without Tears, and the dummies books, these kind of things, and the Statistics Without Tears books I thought was absolutely brilliant, and I recommend it to anyone who's getting into statistics and has not a mathematical background. And after reading these books, I started to really love statistics and probability and flood frequency analysis. There are still lots of reading to do, of course, so I carried on reading, and here's some books that probably on the shelf behind me that I was reading, and I found the best books, and the best way to learn was one of the best ways to learn was to do. So the best books for me were the ones with examples, reproducible examples, so I could test them out and see if my understanding matched what what the book said, and whether I could recreate these examples. And another way of learning that I thought was probably the best way of learning is to teach. So I started rolling out sort of training sessions for my colleagues and writing step-by-step guidance. And in writing step-by-step guidance, it shows up gaps in knowledge. Because you're writing a step and there's a step that you didn't really know, so you have to fill that gap. So it's a really good way to learn. And during this time, around this time, I also did a master's in flood risk management with Newcastle University. But in sort of the teaching to learn role, I also created the Flood Hydrostats website. I don't know if anyone's actually looked at this yet, but the idea was that now this was all sort of had come clear to me, and the FEH started to make sense and all this sort of thing. I decided to try and do what Derek Roundtree did, who wrote that Statistics Without Tears book. For these more advanced subjects. So I created this website, and I've got a little section on extreme value analysis there, and a guide for the UKFE and the flood estimation quick guide, and an example for using these methods to make some maps. It's a work in progress. I haven't touched it for ages, and I should add some more content, but it's there if you want to have a look, and it looks whizzy anyway. So anyway, I thoroughly enjoying the noble pleasure of understanding, and you know, I love seeing a sort of a method that's a bit technical, a bit tricky, and you know, putting some code together, making it work. It's incredibly satisfying. But before I get too philosophical about you know, ways to maximize your happiness through understanding, we should get on with what FEH is and where UKFE fits in. So I've got here the Flood Estimation Handbook Volume 1, which says the Flood Estimation Handbook aims to provide clear guidance to practitioners concerned with rainfall and flood frequency estimation. So essentially, it answers questions such as how often will that flood be exceeded, what flow will be exceeded on average every 100 years, and all very good, and the Flood Estimation Handbook's brilliant. It's got lots of good examples and stuff. However, the methods are very complex and laborious, and quick calculations with a pen and paper are not possible. They require, you know, the methods require pooling data from numerous flow gauges, which are searched and sorted by similarity of catchment characteristics. So these methods aren't really applicable for individuals without software, which costs money. So this is one of the reasons I decided to create an R package which could apply these methods, allowing anyone with a computer to undertake flood estimation using the FEH methods for free. So as I was into statistics, by 2019, I'd gained 3 years of experience in R, and in the summer I joined JBA Risk Management, where I used R all day, every day. It was able to flex my research muscles, which led to a New Year's resolution to create the UKFE R package and to upload it to CRAN, which I managed by December 2020. I resolved to make it all in base R so that it doesn't rely on any other packages. And I did all during the evenings, because when you have 2 toddlers, it's tricky to find other time to do it. So that's sort of where UKFE fits in. And I'll now change my screen sharing to the R platform. There you go. Hopefully you can see the R studio there, and give you a brief explanation of what R is and how it works. So R, this is the R studio. It usually comes in white, but I've changed the color to make it more palatable, and it looks cool this way. So R is similar to Excel in the sense that it does sums and you can store data in it, and you can apply functions. So you can add things together, and so it's very similar, except you don't need the equals sign beforehand. So and you can create columns of data, so vectors they're called in oh my god, so let's put my vector, dot that into matters. There we go. Columns of data, just like in Excel, when you have one column of lots of data, you can put in, I'll just put in some example numbers, 20, 34, there we go. And when you want to have a look at that data, there it is. And you can apply functions to the data, such as mean, and find the mean of the column or vector, and find the standard deviation, etc., or the sum. So all very good. You can also create data frames. So here's 2 vectors I've created beforehand, and using the data frame function, you can create a data frame and have a look at it like so. IDF, and there we are. So just like in Excel, you can have lots of columns of data and things, and you can also plot things such as this. There we go. I'll just move there. However, there's only so many functions in base R, And then when you're undertaking work that is maybe a bit more obscure, such as flood estimation in the UK, you might not have the right functionality. You don't have, for example, the generalized logistic growth factor function. And this is where packages come in. People create packages which other people can download off the CRAN website, install, which is all very easy, and load in with the library function. So UKFE is one such package. Here we are. So load it in, library, UKFE, and it's ready to use. And if we go up here, we can now type in, so this is the packages page, you can type in UKFE and have a look at your package. And this is the package documentation. So each one of these is a help page for one of the functions or some data that's embedded within the package. And they all have a similar format. So this is the AM extract function, and it has a description. In this case, it's quite obvious. It extracts the annual maximum peaks from a data frame, which has dates in the first column and variable in the second. It has the usage, which gives you the command line you need to apply the function, and which has the arguments in there, and then an explanation of the arguments. So X, in this case, the input is a data frame with dates in the first column and variable in the second. And plot is a logical argument with the default true. So when you apply this function, it automatically plots the annual maximum unless you turn it to false. They usually come with a detailed section just to add a bit more information or context that might be useful. In this case, it's noting that the peaks are extracted based on the UK hydrological year, and saying if there are partial years, a bit of a warning that the maximum value may not be the true annual maximum of the year. It also provides the value, which is essentially what the function returns. So in this case, it returns another data frame with water year and annual maximums in the columns. And every function also has examples, which I can show you now. So in this case, it's using an example using some data in the package, which is some data for Kingston at Thames, daily data from 2000 to, if we look at the tail of this data, 2015, and it has the precipitation and the flow. So I'm just going to have to move this thing. It's getting, you won't be able to see this. And the function, if we apply it, you can use the examples in here, just paste them in, and hey presto, you get the annual maximum, and we can have a look at the data. So there you go. So that's a very brief introduction to the function set out and the documentation. This package in particular relies on certain data frames. So, for example, it relies on the National River Flow Archive peak flows, in this case, version 10 at the moment. And you can look at that data. They're all data frames. So this is the annual maximum AMSP, I've called it. So that's annual maximum suited for pooling. And it's got every single one. And it's got this format of date, flow, and ID. We also have catchment descriptors for all sites suited for pooling. So this is just the top 6 when you do the head function. And it's got all the catchment descriptors, easting and northing, QMed, and some L moments and the sample size. We've also got the same for the QMed data, the data suitable for QMed. This actually overlaps and has both the suitable for pooling and QMed data. So I thought what I would do is pick out a site and do some FEH stuff. In this case, I was going to pick out the site with the highest flow ever recorded in the UK. I don't suppose anyone knows exactly what that is. I think you're muted, so you can't say so. But if you know when and where this is, it would be quite impressive. Maybe you were there, who knows? This little line of code orders that annual maximum data from highest to lowest, and this is the highest recorded flow, 2,273 or 4 cumex in 1993, January 17th, and the site is 15006, which I can tell you is the Tay at Ballathi in Scotland. This other site, 15003, is also on the Tay, and here we have site 72004, which is the highest flow recorded in the UK, which is 1,742 cumex, and that was in 2015 December, and that's at the Loon at Caton. There you go, some interesting facts for you. So anyway, we'll pick our site. So we're going to choose the Tayat Blathy, which is 15006, and we'll name it site ID. I'm doing this just so I don't have to type in the number. There we go. And we can extract our annual maximum. Oh, hang on, I missed a bit. Yeah. So first of all, before doing that, I wanted to show you that you can get very quick results with the quick results function. So the quick results function uses a default. So this is getting catchment descriptors, using get CDs for site 4003, and this provides an ungauged analysis very quickly. And this is based on the default pooling group using the generalized logistic distribution, but you can change the distribution in the function if you like. And it provides the return period, the flow, the growth factor, and some confidence intervals, and as well as the pooled LCV and LSQ. And it uses two donors as a default, the two closest sites. And this can also be done for the gauge, and of course does the plot. This can also be done for the gauged case by setting gauge as true. And similarly, you get the same sort of results, but slightly different plot. In this case, quite similar, the pooled and engaged, but yeah. So anyway, that's a very quick way of doing it. But going back to where I was, I've done it in order. Apologies. I'm going to get the annual maximum, do some single site stuff. So using our site 15006, you can get the annual maximum data. And I'll show you what that looks like. It's essentially just extracting that data from the AMSP data frame. So it looks like this. If you want to get annual maximum data, which isn't suitable for pooling, then you can use the import AM function, or AM import function. I forget which way around it is. And you can plot that with the AM plot function. There we go. That gives us a histogram and the bar chart. And we've got a few distributions available in here. So we've got the genlog functions, which generally look like this. And each one has, so we've got the Gumbel, the GV, and the generalized Pareto one. And each has four core functions. So the genlog AM, for example, gives the return level estimate as a function of return period, or vice versa, directly from the data. So you just stick in your annual maximum and it provides you based on L moments. And we've got the genlog est, which provides exactly the same thing, but takes the parameters of the distribution as opposed to the data. And then we've got the genlog growth factor one, which provides the growth factor as a function of LCV and LSQ and of the data, and return period. And then there's the genlog pars, which allows you to calculate pars from an annual maximum series using, and you can use maximum likelihood estimation or L moments. With the generalized Pareto one, it's obviously based on pot data instead, and is called pot instead. There you go, Gen Pareto pot. So without further ado, we can calculate at our Tayat Blathy site the 100-year growth factor by sticking in our flow and our return period of 100 years. There we go. So it's 2,139 QMAX. We also have uncertainty functions, which does some bootstrapping, gives some upper and lower bounds for that estimate, which is quite handy. And we can calculate the parameters as I suggested. There we go. And again, we can do that with maximum likelihood estimation if we want, by putting that to true. So similar, but slightly different. And using our genlog est function, again, we can calculate the return period, which should be exactly the same in this case, unless I use the parameters done by maximum likelihood, of course, which I'll stick in, just see what the difference is. So quite different, but within the upper and lower confidence intervals for the 95% case, let's see if it's within them for the 68 confidence intervals. It is just, there we go. So where are we? Oh yes, so we can also get the generalized growth factor, as I said, using the LCV and LSQ of the data, which I've put in here. Now, one thing I wanted to calculate was the return period of that flow that was the highest observed flow in the land, as it were. And the return period is 144 years. Although some might suggest there's a bit of a trend in the data, so maybe we should take that into account. There is a trend test function, which uses either Kendall or Spearman or Pearson's method, and it provides a p-value for you. In this case, the p-value is 0.04. So we might want to say, yes, okay, there's a trend there. Let's see what the return period is if we account for trend. And in this case, you can put, in the genlog AM function, you can put trend equals true, and this allows the location parameter to change with time. And that suggests the return period, or the likelihood of that happening is a bit less now. It's now a return period of 97 years. And we've got, for the single site case, we've also got some plotting functions, the extreme rank plot and the flood frequency curve with confidence intervals. So there's the frequency curve for Lathi, and there's the extreme rank plot. There we go. So there's the single site thing, and now we're going to do some ungauged analysis. And then on to some gauged, but pooling analysis essentially. So for pooling analysis, we need to get. So as I said, you can do it very quickly with these sort of quick results functions, but we may want to be a bit more discerning and fettle our pooling group and have a think about it. So you can get CDs by using this get CDs function. And again, if you can't, if that's only for sites suitable for pooling or QMed, and if it's not in one of those, you could use the import CDs function and import CD3 files, which are available through, for a peak flows or the FEH web server, of course. So descriptors, there we go. So we can look at our descriptors, which look like that. Lots of useful information, and we can use a QMed function. So as you probably know, the general method is calculate QMed, calculate the growth curve using the pooled data, and then multiply them together. So if we use the QMed function, we can get our ungauged QMed, which is 825, but we may want to use the donor adjustment, and in this case you can use the don-adj function, which provides a list of close sites and all of them in closeness with the distance here for you to choose donors. In this case, we've actually got the site in question in the list because it's actually gauged, and we're pretending it's not. So what we'll do is take the next two sites in the list and use those as donors by using the donor to argument. And hey presto, we get an updated QMed. As this is a gauge site, we can see how our improvement works. So we can say get QMed, stick in our site ID. So we have actually got a bit closer to the gauge. It was 825 and now it's 987. There we go. So we now want to do our pooling group, and we have a pool function. So hopefully it's all very intuitive in that site. We'll exclude our site ID, our site, because we're again pretending it's ungauged. So here's our pool group. You can have a look at that. There you go. And so it looks like we've got 1, 2, 3, 4, 5, 6, 7 sites in our pooling group, and it's got all the usual information with catchment descriptors, some L moment and L moment ratio type statistics, sample sizes, similarity, distance measure, discordancy, etc., etc. And we can do diagnostic plots. And some of these plots may look familiar to some of you. This provides a plot of where all the gauges are. And there's the L-skew versus L-kurtosis plots you can use to see if your sites are, or any of the sites are well out of the range, and also plots to see where the sites are in regards to the rest of the distribution of certain catchment descriptors. So here we are. So we've got a file there which is a bit out on a limb, could be investigated, but yeah. So these are the general diagnostic plots, and we have the H2 function for homogeneity and the zdist function for choosing distributions. So the group in this case is homogeneous, and the generalized logistic has the best fit, which is all nice and easy, so we won't change anything. And then you can use the pool est function, put in your QMed estimate, and it should give you a result. There we go. So again, we get the return period, the flow, the growth factor, and some uncertainties, and the pooled LCV and LSQ. And you can do an EV plot, frequency curve plot using the EV pool function. Ta-da. Again, the input there is just the pooling group that we created. And as this is ungauged, we may want to use REFH to do a design hydrograph. So the REFH function is you stick in your catchment descriptors, and it sticks out, pulls out the usual RFH type information with all the parameters and the initial conditions and all the results here. But for now, we're not overly excited by all that because we're just using it to scale. So up here we found our 100-year flow was 2088. So we're going to use that with a scaled argument to create a scaled hydrograph for our ungauged site at Balathy. There we go. So there's our design hydrograph for our ungauged site. Good stuff. So we can do all the same stuff with the pooled analysis. Gauge, so enhanced single site basically. So in this site we can say it's with the pool we'll create our pooling group as per before, and then we'll stick it in, but say gauged is true with the pool est function, and use the gauged QMed. And hey presto, we get our results. And again, we've got the EV pool function to create a plot. In this case, the single site and the observed are pretty similar. And we have an uncertainty function although we have uncertainty calculated here, this is a sort of an approximation and based on results from this uncertainty function, which does a bootstrapping procedure to create our results. The default is the 100-year return period, but we could change that, and we can see how similar these are actually to this, so not too dissimilar. So we can change the return period to say, I don't know, 250. There we go. Get results. Now we've got our enhanced single site estimates. We may want to recalculate that return period for the maximum flow. So I'll pull out just the first two columns of that of those results. So the same as this column or this data up here, but the first two columns. And I have this optim pars function, which I find exceedingly useful. Essentially, when you've got, sometimes you have a report or something, and it just has the return period and the flow and no other information. So it's quite useful to be able to put that into this optim pars function, and it gives you the parameters for whichever distribution you stick in. In this case, it's the gen log, but it could be the GEV, etc. And using that, we can then use our gen log est function, stick these parameters. Oops, sorry, bear with me. We can then calculate the return period of that maximum flow we were talking about. So we've got our Amax still, the flow, and the return period in this case is 127 years. There we go. So that's the gist of the FEH functionality. There are obviously more complicated cases, such as when sites are urban, etc. So, for example, if you use the QMed equation on a site that's urban, so I'll just choose the Kingston one, it'll give you a warning and recommend an urban adjustment, which you can add. And hey presto. And similarly with the pooling, you can urban gauges are by default excluded, but you can include them using the IUG, include urban gauge option, and you can do, change the growth curve by urban adjustment, etc. So that's the main FEH functions, and there's a few more functions I want to show you. One is, I showed earlier that we've got an annual maximum extraction function. We've also got a pot extraction function. So here we have the pot extraction for the flow at Kingston, and it tells us we've got 1.86 or 87 peaks per year in this case. We can also do it with the precipitation. There we go. And just as a test, I'm going to do a generalized Pareto distribution assessment of the 100-year for the precipitation over the catchment. And you have to put in the peaks per year here, and that gives us 71. And if we take out the annual maximum sample and use the GEV, we can see how similar they are. So both get around 70 millimeters, which is nice and satisfying. Right, more functions to come. There's the BFI function, the base flow index function, which does exactly what it says on the tin, I suppose. Again, using the flow data at Thames, gives you the BFI, 0.58 in this case, and it also gives you a plot showing the split of the hydrograph. For these next two functions, I'm going to read in some data for the loon at Killington. There we go, and I'll show you what that data looks like. So it's hourly data, and it's got the precipitation and the flow. The first function I want to show you is the hydro plot function, which does this. There we go. So it plots the flow at the bottom and the precipitation at the top. That's all the data, so it's not overly informative plot at the moment, but using this command line, I can pull out the largest flow in the series there and hone in using the hydroplot function, using the from and to options and putting in the dates. So in this sense, we can pull out a nice satisfying plot that looks like that. So for the function for the hydro for the loon, got a design hydrograph function, which does what it says on the tin, I suppose. It essentially looks at the flow data, picks out a default, I think, of 10 peaks, and then scales them to 1 and lines them up, and then takes the average. And you can truncate that using the XST and XEnd functions and create a design hydrograph. So the hydro loon that we've created, that's the design hydrograph, so scaled to 1. If we use our quick results function again with the loon catchment, which is 72005, we can get the 100-year flow, which is 641, and we can then multiply that by the loon hydrograph, which gives us a nice design hydrograph at loon at Killington. There we go. So, right, how many more functions? Not too many. So 2 more functions and then just a lastly bit. So this function actually relies on some data I'm going to get from another package. So there's another R package called RNRFA, which many of you probably heard about. It's a very good package and specializes in extracting data from the NRFA website. And in this case, you can get some gauge data. So again, I'm using our site at Balathy and pulling out some gaugings for flow and stage. And this we have, oops, sorry, 166 gaugings, and we can use a rating function, which is in UKFE, to plot it and provide a rating curve. And the rating curve provides the parameters, provides the equations for discharge as a function of stage, and stage as a function of discharge. And as you can see, this doesn't fit overly well because it's just fit through all the data. So you may want to subset the data and provide limbs, as it were. So maybe everything below 1 and everything below, and again, you get the same outputs with the parameters and the equations, and then between 1 and 2. There we go, nice. So the last function I thought I'd show is the encounter probabilities. So the encounter probabilities function allows you to calculate things like the probability of exceeding at least one 50-year RP event, return period event that is, over a 10-year period. So you stick in your number of exceedances, you stick in your years and your return period, and it tells you the probability of that happening. So in this case, 0.18, and another one, calculate the probability of exceeding it at least 2 100-year RP events over a 100-year period. So I'm sure lots of you have got it right at the top of your head, and it's 0.26. There we go. So that's all the sort of functionality I want to show you, but I also want to demonstrate that that one useful thing of this package, as well as applying the methods, is research. Because it's a command line based system, you can essentially fettle anything, and you can change your pooling group as much as you want once it's being created, or change functions and create new ones. Obviously, just call it a different name. And you can also loop through and get lots of data. So I've just set off a function which, well, two loops. One loop is getting all the growth factors for sites suitable for pooling, and another loop, which is finished now, is getting all the ungauged results for all the catchments suitable for pooling. And with that, you can do analysis, of course. So we can see this is a summary of the 100-year growth factors. So we can see the mean growth factor is 2.65 and the median is 2.45. And I'll show you the first few columns of that other loop, which was getting all the ungauged results. So this is, of course, useful. So, for example, if you wanted to test different similarity distance measures in our pooling assessment, you could change it within the function, run the loop beforehand, then change it, run it again, and then see which does better in regards to fitting the results for our pooled against enhanced single site or single site itself. Sorry. we can also do plots of data that's already there. So as I showed you, we've got the data from RFA for some sites suitable for pooling, etc. So simple plots of the sample size is interesting, or the summary of the sample size tells us useful facts, like what is the median sample size and what is the median LSQ or LCV. And when we're doing our pooling analysis, we can then see the ranges in which things like the Cumming equation are calibrated. So we can also find, here's a box plot based on the proportional error in Cumming estimation using the Cumming equation. And we can find out how many sites out of those 855 underestimate Cumming. So 0.59, which is quite a few. So that's about the gist of what I wanted to say there. I'll go back to my PowerPoint presentation. Yeah. Hold on. Where's my button? Oh, I seem to have lost the. Oh, there we go. There we go. No. Current slide. Yes. So aside from those functions, I'm hoping to add more. There's the small catchment pooling functionality, flow duration curve plotting function to add user sites to pooling groups, the depth duration frequency plots, kappa growth curve function, and a generic time-based stats function. So for example, we've got the annual maximum function at the moment, which picks out the maximum per year, but it'd be nice for the user to be able to say what's the average flow for June or July or seasons. Maybe a design precipitation profiler, who knows? So anything's up for grabs. So I guess hopefully after seeing all those that functionality, you can answer that question whether any of this is going to be of use to you, and if not, you can always suggest extra functionality and maybe even add your own functionality. But if you aren't keen to do that, you can always provide feedback on what's already there about messaging and error messages and actual errors, etc. And at the very least, join the mailing list for updates, which you can do by emailing floodhydrostats@gmail.com. That's about it. Thank you very much.
Thanks very much, Anthony. That was really useful. I think I definitely should be able to use it, and I'm sure loads of other people will as well. So if anyone's got any questions, please post them in the chat. I don't think we've got anything currently, although we did have somebody who knew exactly when the highest flow was.
Oh, really? That's good.
Yeah.
I thought there would be at least one.
So a question has come in from Adam. Which version of the peak flows data set is in the package, and will it be updated?
Yes, it's version 10 at the moment, which I think is the most, I hope is the most up-to-date version, and my plan is to update it every time the version updates. So yes.
Great, thanks. Chris Parker has said, great presentation, thanks, love the package. Have you benchmarked against WIMFAP, and have the EA approved the use of UKFE for UK projects?
Yes and yes, I suppose is the answer. So yes, I've benchmarked, I did some testing with the help of my colleagues at JBA against WIMFAP, and I think there's an I can't remember what it's called, but there's the EA have a site online for flood estimation guidelines. It's not the actual flood estimation guidelines, but something similar, and they recommend it in the UKFE package. So in that sense, I guess they've endorsed it.
Sorry, I just it's Rob Burton here. I just had a quick question. Is this something you've created, or is this JBA you've created this, or what's going on?
Yes,
it's taken you a lot of time.
Yeah, I created it in the evenings over the year of 2020.
Okay, lockdown time. Yeah. Okay, very good use of your time. Excellent.
Okay, I've got an anonymous question or statement saying, not 100% sure that distributing the peak flow data in the R package is compliant with the NRFA terms and conditions.
Oh. Distributing the NRFA data, the peak flows.
Possibly. I don't know if that's something you know the answer to straight away or something to possibly think about later.
Yeah, I did read about it. I couldn't see anything that suggests I shouldn't. So yeah, hopefully not. Otherwise, it's scuppered the whole thing. I have to think of a different way of doing it. I mean, there's always you know, and WinFAP does that, doesn't it? So I don't know.
Yeah. Another question, which from Louise Parry, which actually I had as well. Which version of RefH is the function based on?
That's the original RefH that Thomas Kelton did in 2007.
Is there any way of potentially getting RefH2 in there?
No, it's
I assume not. They've hidden the calculations.
Yeah, there's some things hidden, and I think it's copyrighted in certain ways, so a bit tricky, really.
Yeah. I don't think there's any more. Oh yeah, no, another question. So someone's already found UKFE of use on 2 projects, and he commends you for your effort in producing this for the community. Do you plan on sharing cases to build up an open source community?
Sharing cases? What does that mean?
Sharing used cases, yeah.
Oh, I see. Could do. I mean, I like the idea of building up a community of people, suggesting and maybe even adding what do you call it, functionality. So you may have noticed that in the function documentation, there's a thing that says the author, and they've all got my name at the moment, but we could always add other things and put whoever created its name on there.
Great. Daniel Hamilton has asked, is the permeable adjustment procedure built into the R code, or does this need to be applied externally?
There is a permeable adjustment function in there, yes. So you can any annual maximum that you want to apply it to, you can apply it. Gives you the adjusted LCV and LCQ, which you can then change in your pooling group if you need to.
Great. So another question, have you any recommendations on resources to get started with R or R Studio for a novice user? Which might be useful for quite a lot of people. Yeah,
the R for Dummies is a pretty good book. And I did have an e-book that was pretty good, but I'm afraid I can't remember the name of it. Those are the 2 books that got me started. I did try. I'm not very good with those online courses things, so it was mostly just yeah. And for me, it was just using it, trying to use it in place of Excel for as many things as I could, and then getting better at it. It is a very steep learning curve if you've done no programming.
It did look like it could do a lot more than I kind of originally thought, which was useful, like a lot of the Excel stuff. Anyone else got any more questions? Don't think there's anything new in the chat at the moment. Oh yeah. So there's lots of statistical functions common to high and low flows. Would you consider extending this to cover low flow analysis?
Why not? Yep. Yeah, I've got the base flow index, and then yeah, as you say, some of the functions are overlapping. So yeah.
I've got another question about the IPR. As it's free, will it bypass the need for WinFAP and other CEH products?
Well, CEH provide all the catchment descriptors, and so you have to pay for those. So you can get the catchment descriptors for sites suitable for QMed and suitable for pooling, but you can get those anyway from free from CEH and the FEH web service. The NRFA website, and any catchment descriptors for ungauged stuff, that's all FEH web server stuff, so you have to pay for that, unfortunately.
Thanks. Any other questions?
I'll have one more question. How long have you spent on this?
I don't know really. It's hard to tell because as I was, as I said in that beginning of the presentation, I was trying to recreate stuff, and in R I created some functions which I used elsewhere and brought them all together, kind of thing. But I have no idea. It must be quite a long time now. I think it took a year of sort of evening, not every evening, of course, but a long time. Hard to say.
Yeah, no, it's remarkable and very impressed.
Thanks very much.
Another slightly awkward question. What commercial impacts do you think this could have on FEH software and licenses? And if it does, would this undermine UK standard methods in a way we may not wish to see?
It doesn't have to. I mean, it's essentially just applying the methods that are there. So as long as I don't go off piste and start making up my own methods and whacking them in there, and hopefully, as suggested, a community can build around it. The only difference is it'll be free, which the environment agency have a goal to open things up, open data, and open methods, and I fully believe in that approach and think that the more people have free access to all this sort of stuff, the more people use it and have ideas of how to improve it, the better. So yeah, I think it should be okay. And it's not going to be detrimental, I wouldn't say.
Yeah.
Thing is the way I'm looking at it.
It did look like it just provided a lot of functionality that previously we had spreadsheets set up to do things like that. Chris Parker has just commented that going forwards, the UK hydrology roadmap promotes open source methods, which I think is what you were saying about the EA promoting open source methods.